All right, for our next special segment in triangles, we're going to be using medians, okay? So let's first talk about what is a median. The median of a triangle, okay? It connects a vertex to the midpoint of the opposite side. So from this vertex to the midpoint of the opposite side, that is the median. This segment is the median. So here we have a vertex to the midpoint. How many medians can you draw in one triangle? Correct. You can draw 3 because there's 3 vertices. So I can draw one from here to go there. I can go one from here to go there. As you see, they will all intersect at one point, right? They will all intersect at one point. That point of intersection is going to be called the centroid. The centroid is where the 3 medians intersect. So let's find here the exact medians. Okay, let's find the exact medians. Let's start with the median to AB. So we're going to need the midpoint of AB. -5 plus -1 over 2, -6 plus 8 over 2. 6 over 2, 2 over 2, -3, 1. 1, 2, 3, 1. Okay, now, if it's the midpoint, if it is the midpoint of AB, the median will come from C. Let's check the midpoint of BC. 9 plus -1 is 8 over 2, 18 over 2, 4, 9. 1, 2, 3, 4, 9. 1, 2, 1, 2. So let's draw that line. Right? You would use your rulers for this. You connect the vertex to the midpoint. And last, I need the midpoint of AC. -5 plus 9 is 4. 10 plus -6 is 4. 2, 2. From B to C. So now we have our 3 medians, and they all intersect. 1, 2, 3, 4. At 1, 4. The centroid is 1, 4. The intersection of all 3 medians is called the centroid. Okay? The intersection of all 3 medians is called the centroid, and right here is my centroid. Okay?
Dave Allen 2519, Dave Allen 2519.
I apologize about that. People are on the loudspeakers. Okay, so the centroid of a triangle. It is known as the center of gravity. This is the center of gravity of a triangle. So if I were to take this here, right, and I were to cut it out and place my pencil right there, this would balance perfectly on my pencil. Now in school, what I'll usually have you do is I'll have you draw the median, draw a triangle with all 3 medians, and then try to hold it on the tip of your pencil. It can definitely happen. It's pretty cool. Try it on your own. You take out one of these blank graphs, print it out, cut it out. You don't have to do it, but it's something you can do. It's pretty interesting. We do it when we're live in school. Unfortunately, we can't do that this year, but it's cool. Do it with this. It gives it a big enough space. Cut it out. Hold the pencil point on the centroid. It'll balance. Okay. Now, in the past, we would have to find the equation of all these lines to find it. Well, there's actually a formula. There's a formula to find the exact coordinates of the centroid. Okay? So if you're drawing a centroid and say it happened there, right? It wouldn't in this particular triangle, but in general, if the centroid was not an exact point and you needed to find it, instead of finding the equation of the 3 lines, you could use this formula here. Add up all the x values, divide by 3, add up the y values, divide by 3. You're basically taking the average of the x's and the average of the y's. Similar, I guess, similar to when we would find the midpoint, right? But the midpoint's only 2. This is actually a triangle, so it's 3. So to find this point 1, 2, if we add up all the x's and divide by 3, and then add up all the y's and divide by 3, we will get that point. Let's check it out. -7 plus 0 plus 10 over 3. 5 plus 9 plus -8 over 3. Okay. -7 plus 10 is 3 over 3. 14 minus 8 is 6 over 3. 1, 2. Look at that. That is my centroid. That is my centroid. Okay? So make sure you know this formula. Okay? I will probably have you find the centroid by graphing and then check the centroid by using the formula. So you definitely have to use this formula. And it's a pretty easy formula, so you can check to make sure you at least graphed it the correct way. Again, add up the x's, divide by 3, add up the y's, divide by 3. Okay? And we have one more thing about our centroids. Okay? Centroids gives you a nice ratio. Okay? It gives you a ratio. What this is saying is it says the distance from the vertex to the centroid, this distance right here, will always be 2/3 of the distance of the entire median. So 2/3 times the median is equal to the distance of the vertex to the centroid. So vertex to centroid is equal to 2/3 the length of the median. So if this whole thing was 12, 2/3 of 12, this would be 8. Okay? The length from the centroid to the vertex is 2/3 the whole median. So let's look at this. C is the centroid. HR, so this whole thing, is 9x minus 21. They want us to find HC. Well, the distance from the vertex to the centroid is 2/3. So it's 2/3 the median. HC. 9 divided by 3 is 3, times 2 is 6x. 21 divided by 3 is 7, times 2 is 14. So that will be the length of HC. There's no values here. We can't solve for an actual length, but that's just in terms of x. Okay? So that's our median. Our median is the intersection, our centroid is the intersection of 3 medians. A median connects a vertex to the midpoint of the opposite side. The length of the median, right, has a ratio compared to the vertex to the centroid. From the vertex to the centroid is 2/3 the length of the entire median. We have some problems for you guys to try, then we'll come back and do them together.